Hello everyone, today we are diving into explainable artificial intelligence or explainable AI. So why is explainable AI becoming such a hot topic in the AI world? Well, let's face it, AI is everywhere, making critical decisions from medical diagnosis to credit approvals. But here's the catch, many of the systems are like black boxes. They give an answer, but we don't always know how they got there. And that's where Explainable AI comes in. Explainable AI tackles two major issues: transparency and interpretability. Imagine an AI system that helps doctors read chests, X-rays. It makes predictions, but it doesn't explain why it labeled one X-ray as pneumonia and another as normal. That's not ideal when people's lives are at stake, right? With Explainable AI, we are not only get predictions, but also the reasoning behind them. This improves trust and helps us catch potential mistakes, especially in critical sectors like healthcare and finance. So, what makes Explainable AI so important? Let's break it down. First, explainability helps us fix problems when the AI gets things wrong. Second, it allows us to understand patterns in the data that the model picks up, maybe even revealing new insights. And finally, explainable AI ensures AI systems meet legal and ethical standards by being transparent and accountable. But how do we make AI explainable? There are several approaches and they fall into four key dimensions: data, model, outcomes, and the end user. Let's start with data. Explainable AI methods helps us understand which features of the data were important for the model decisions. Next, we look into model itself. Does it explain how the input leads to the output? And more important, can it explain this in simple and understandable terms? Now let's talk about the outcome dimension. This is all about explaining the result the model produces. In this dimension, explainable AI focuses on giving clear reasons for a specific prediction or decision, helping users understand how certain inputs lead to certain outcomes. Finally, there are end-user dimension, which might be the most important one. It ensures that both technical and non-technical audiences understand the AI decisions and feel confident using the system. In this context, we have different types of explainability. Explainable AI techniques can be local or global. Local explainability focuses on explaining individual predictions, while global explainability looks at how the model behaves as a whole. Then we have intrinsic and extrinsic explainability. Intrinsic methods are used when the model itself is easy to understand. Extrinsic methods, also known as post hoc methods, are used to explain complex models. Then we have model-specific and model-agnostic methods. Model-specific explainability are tailored to certain types of algorithms, while model-agnostic methods can be applied to any kind of model. Finally, we have model-centric and data-centric approaches. Model-centric approaches focus on how the algorithm processes the input features to create predictions. On the flip side, data-centric methods focus on the quality and the consistency of the data itself. One key challenge in explainable AI is balancing accuracy and interpretability. More complex models, like deep neural networks, tend to be high accurate but hard to explain. On the other hand, simpler models like linear regression or decision trees are easier to explain but might miss out on complex patterns. Finally, let's talk about how we evaluate this explainability method. There are three main approaches: application-grounded, human-grounded, and functionality-grounded evaluation. In application-grounded evaluation, you test the explainability of the model in real-world applications with actual users. Human-grounded evaluations, on the other hand, involve non-experts in more controlled experiments. And lastly, functionality-grounded evaluation focus purely on the model's behavior without involving any human users. In short, explainable AI helps us build trust in AI systems by making their decisions more transparent and understandable, while balancing accuracy and interpretability.